Hi, I'm Guang, 50 years old. In this lesson on limit calculation, we're taking a look at this example we had in a previous lesson, where we used method 1, rationalization, special limit, and Maclaurin's series. And the example is limit x approaches to 0, square root 1 plus sine x plus sine square x minus bracket alpha plus beta sine x over sine square x is equal to 3 over 8. And we're given also that alpha and beta are both greater than 0. So we need to find the values of both alpha and beta. Right, so now we will be taking a look at the two other methods. So in method 2, what we will be using is rationalization. So in this method of just rationalization, again, it is more of a numerator rationalization. Well, we have limit x approaches to 0. So since it is a 0 over 0 form, as when you substitute the x in, you would immediately realize the denominator becomes a 0. And since you get an actual value, something that exists, which is 3 over 8, that means your numerator has to be 0 when you substitute x inside. Right, so with that information, it means that you can use this kind of rationalization, and in the numerator you have to multiply on an a plus b form, alright, which will give you something like 1 plus so you have 1 plus sine x plus sine square x. Then you have to subtract alpha plus beta sine x squared. Then this is divided by sine square x, and you also have to multiply square root 1 plus sine x plus sine square x, then subtract alpha plus beta sine x. Alright, so this is the form that, wait, this is a plus, sorry about that. Alright, so this is the form that you are looking at. Okay, so what's so special about this? What you can do next is to substitute x into the other part in the denominator. Now, why can we do so? There are two things that I have to look out for. The first thing is that when substitute x in, you have 1 plus alpha. Well, since alpha has to be greater than 0, it means 1 plus alpha cannot be 0. So it does exist. And since it does exist and it is multiplied on to this other part, the fraction, since it is multiplied and it is not equal to 0, and of course it exists, which means you can directly substitute x into the latter part. Alright, so what we're going to do now is let's take a look at the numerator. We can group the numerator into a few different parts. And by that, I mean the constants, which is 1 and alpha squared. Then the terms of sine x, which is 1 minus 2 alpha beta sine x, and the terms with sine square x. We're going to have plus 1 minus beta squared sine square x. And this will be divided by 1 plus alpha sine square x. Right, so how do we proceed from here? Now, in this part, what you have to realize is your variable kind of just seems like it's just sine x, right? Right, so since it's just sine x and x approaches to 0, which means sine x are those terms that approaches to 0. Now, since these are terms that approach to 0, you can think of it as three different parts. Now, in the first term, where you have 1 minus alpha squared divided by something that approaches to 0, if 1 minus alpha squared is something other than 0, the entire thing becomes infinity, which is not right. So 1 minus alpha squared has to be 0, right? And 1 minus 2 alpha beta would also have to be 0. Okay, so from these two, you can then determine what your alpha is, which is 1, since alpha has to be greater than 0. So negative 1 is rejected. And next, you find your beta, where you just substitute alpha into the second part to get beta is equal to half. Right, so alpha is 1, beta is half. How about the other term we didn't look at? Now, this other term, which is essentially 1 minus beta squared divided by 1 plus alpha. So you can just substitute in alpha and beta to get 3 over 4 divided by 2. Well, here you should realize that it is equal to 3 over 8, which is what we are given, alright? So, since these two both have sine square x, you can just simplify that and you won't have that limit anymore, alright? So, solving for your original thing, you get 3 over 8, which is right. If you get something else, there has to be something that went wrong, right? So this is the second method, using rationalization. Okay, so this part of rationalization, what will be so special about this? So the third method would actually be using the L'Hopital's rule. Alright. So of course, if you can technically just say that this is equal and just ignore the part in between. Right, so the third method, L'Hopital's rule. This limit here given, it has to be of a 0 over 0 form. Alright, so it has to be of a 0 over 0 since in the denominator, when you substitute in x, it approaches to 0. And your final result is a 3 over 8, not something that does not exist. So your numerator has to be 0. But of course, even if your numerator and denominator are both zeros, the limit might not necessarily exist. It depends on what kind of question you're looking at. So since it's a 0 over 0 form, and they're both continuous differentiable, you can use the L'Hopital's rule. Alright, so limit x approaches to 0. Now we just have to differentiate both numerator and denominator. So differentiating for both, in the numerator, the first term you do have a square root. So it's a rather complicated part of the chain rule. Oops, I missed out the 1, alright. So half, there you have cosine x plus 2 sine x cosine x. Right, so this should be the first term that you're seeing. And next, the second term, where you have minus alpha. Alpha differentiated becomes 0, and you're just left with minus beta cosine x. Then in the denominator, you have 2 sine x cosine x. Right, so this is what you're going to see after you've used the L'Hopital's rule once. So the next step, what you can do is either, so you might want to just first take a look at what kind of terms you have here, right? Now, in the first fraction in the numerator, you have cosine x plus 2 sine x cosine x divided by this entire bunch, then minus beta cosine x, and then divided by 2 sine x cosine x. So what kind of form is this right now? So you do have a cosine x, then add on to, if you substitute x in, that becomes a 0. So cosine x, that will be divided by 2 if you substitute the x in, then cosine x over 2 minus beta cosine x. Then this is divided by 2 sine x cosine x, where if you substitute the x in, that will still be 0. Right, so what exactly can we get from here? One thing you can do is, of course, to count denominator among the numerator, then bring your denominator of the numerator down into a denominator, and of course simplify your cosine. At the same time, we are going to common denominator this entire thing and put the denominator down. So we will have limit x approaches to 0. Cosine becomes 1 plus 2 sine x cosine x becomes plus 2 sine x, and then you have to minus 2 beta square root 1 plus sine x plus sine square x, and the entire thing is divided by 2 sine x square root 1 plus sine x plus sine square x. Right, so this is a term that we are going to see. Now, we take a look at this again. When we substitute in x is equal to 0, 2 times 0 times 1, so this part behind, you could actually substitute x is equal to 0 in already, since this term is just 1, and it is multiplied onto whatever fraction you have here. Well, you might think of it as divide, but multiply, divide, they're both pretty much the same operation, alright? So, this part you can just already make it become 1. Then you have 1 plus 0 minus 2 beta. But now that seems a little bit weird, isn't it? So if you substitute x in, you have a 1 minus 2 beta over 0. But your answer here is 3 over 8, which means your numerator still has to be 0 to form the 0 over 0 in order to actually be able to solve this limit. Right, so now that you have that 0 over 0 form, which also suggests that beta is essentially half. So with that, limit x approaches to 0. So what you're going to see now is essentially L'Hopital's rule for a second time. 1 becomes 0, 2 sine x becomes 2 cosine x, then minus 2 beta, so beta remain on the outside. This part behind differentiated is just whatever you see over here. We're going to have over square root 1 plus sine x plus sine square x. And in the numerator, you're going to have cosine x plus 2 sine x cosine x. And this is divided by 2 cosine x. Alright? So this is what you will be seeing. And now at this stage, it is no longer a 0 over 0 form. So you can just directly substitute them in. And what will you see? So there will be 2 minus. So this part is a 1, this is a 0, so it's just 1 over 1, which is just 2 minus beta divided by 2. And this has to be equal to 3 over 8, alright? So, wait a minute, there's a 2 here, sorry, there's an extra 2, so this is 4, and this is 4. So this is over 4, sorry about that, alright? But this is right now. Okay, so there's 2 ways to get beta from this step. It's either you solve this part, or you just immediately deduce that beta has to be half. Alright, so beta is half, but what is alpha? Alpha, you have to go back to the original question and you think about it. A 0 over 0, but if you substitute x in the numerator, you're going to have 1 minus alpha. And since you have a 1 minus alpha that has to be equal to 0, that means alpha has to be equal to 1, alright? So if you want to write out the simultaneous equations, that would just be 1 minus alpha is equal to 0, and 1 minus 2 beta is equal to 0. Alright, but then you just put these two below. Alright, so this is essentially how you get alpha and beta. So these are the 3 ways that we have taken a look at it. The first method, with using rationalization, the special limit, and Maclaurin series. So if you want the details of the first method, you could go back to the previous video. But here, we used the second method, which is just rationalization. Pretty similar to the first method, except you branch off earlier to get this step instead of then using Maclaurin series on this sign, alright? So then afterwards you get simultaneous equations, show that it is right, and that alpha is equal to 1, beta is equal to half. Or for the third method, just using L'Hopital's rule, we used L'Hopital's rule once, simplified it, used it again, and formed simultaneous equations. And you just solve this simultaneous equation in order to get alpha is equal to 1, beta is equal to half. And once again, you can also show that it is 3 over 8, alright? So, I hope for these 3 methods, you're clear of all of them so far. I will be ending this here, and thank you for your watching.